If AI agents are becoming software teammates, MCP servers are one of the big reasons they can do real work. A model by itself can talk, reason, and draft, but it usually cannot see your current files, query your database, open your ticket system, or call your private API. An MCP server is the bridge that exposes those outside capabilities in a standard way. The goal is not to memorize jargon. The goal is to build a mental map so when somebody says install an MCP server, you know what is being connected and what should be checked. In this separate 8-minute video, we will cover the history of MCP servers, how they work, how to use them, their benefits, the risks, and a small test at the end. The story starts with a practical problem. As AI assistants improved, they still lived behind a wall. Every product needed a custom connector for every data source, and every data source needed special work for every AI app. On November 25, 2024, Anthropic introduced and open-sourced the Model Context Protocol to reduce that fragmentation. The early idea was simple. Instead of rebuilding integrations again and again, expose data and tools through a shared protocol that AI applications can understand. MCP did not replace authentication, product design, or user review. It gave the ecosystem a common connection language. MCP then moved quickly from a connector idea into a broader ecosystem. The official project includes the protocol specification, SDKs, development tools such as the MCP inspector and reference server implementations. By December 2025, Anthropic said it was donating MCP to the Agentic AI Foundation under the Linux Foundation, with support from major AI and cloud companies. That matters because MCP is meant to be vendor neutral. A server should not belong to only one chat app. A registry also matters because discovery becomes easier. Teams can find existing servers before writing another private connector. An MCP server is a program that exposes focused capabilities to an AI application through standardized interfaces. It might provide file access, database queries, GitHub operations, Slack messages, calendar events, browser automation, or company-specific APIs. The server is not the model, and it is not the whole AI app. Its job is narrower. Describe what it can offer, accept valid requests, perform allowed work, and return structured results. Treat each server like a small service with a contract. Here are the inputs, here are the outputs, and here is the boundary. MCP servers usually expose 3 main building blocks. Tools are executable functions like run a query, create an issue, or fetch the weather. Resources are readable data like a file, a database record, an API response, or a schema. Prompts are reusable templates that guide a workflow. A good server names these clearly, validates inputs, and keeps each capability small enough for a user or host application to review. When the host lists these primitives, the model gets a menu of possible actions without needing to know every integration in advance. MCP uses a host, client, and server architecture. The host is the AI application the user interacts with, such as an IDE, desktop assistant, or chat product. The host creates one MCP client for each connected server. That client maintains the protocol connection, negotiates capabilities, lists available tools, and routes calls. The server stays focused on its own domain. This separation helps keep boundaries clearer than one giant integration. Servers should not need the whole conversation or visibility into other servers. The host is the place where coordination and user consent should live. MCP servers can run locally or remotely. A local server often uses Stdio, which means the host launches a process and talks through standard input and output. That is common for file system tools because the server runs on the same machine. Remote servers commonly use Streamable HTTP, which supports network access, streaming, and normal web authentication patterns. The choice changes your security model, so always know where the server runs and what data it can reach. Local does not automatically mean safe, and remote does not automatically mean unsafe. The important questions are identity, permissions, logs, and data flow. Beginner usage flow is simple. First, choose a host application that supports MCP. Second, pick the server you actually need, such as file system, GitHub, Postgres, Sentry, or a company API. Third, read the server documentation and configure it with the exact command, arguments, environment variables, or remote URL. Fourth, restart or reconnect the host. Inspect the listed tools, and try one harmless request. Only after that should you let the agent use the server for real work. If the tool names surprise you, stop and read the config again. A good setup should be boringly clear. If you build your own MCP server, start tiny. The official tutorial pattern is a simple weather server with 2 tools, such as getting alerts and getting a forecast. That is the right size for learning because you can test each tool, read the schemas, and understand the full request and response path. That is the right size for learning because you can test each tool, read the schemas, and understand the full request and response path. Use the MCP inspector or a similar tool to call each function before you trust it inside an agent. One important detail. For Stdio-based servers, do not write logs to standard output, because that can corrupt the JSON RPC messages. Use str or a log file instead. Benefits are practical. Developers can build one server and reuse it across multiple compatible clients. Teams can expose internal tools without pasting sensitive data into prompts. AI apps can discover available tools dynamically instead of relying on a hard-coded menu. Users get clearer consent moments because a tool call can be named, described, and reviewed. And companies get a cleaner path from experiments to production because connectors become modular. For creators and learners, the benefit is simpler too. You can give an assistant real context without dumping everything into one long prompt. The same power that makes MCP useful also creates risk. A poorly scoped server may expose too much data. A vague tool description may cause the model to call the wrong action. A remote server may introduce authentication, privacy, or logging concerns. So the rule is least privilege. Give the server only the access it needs, keep secrets out of prompts, review tool calls before destructive actions, and test failure cases. MCP is a protocol, not a permission strategy by itself. For production, also think about versioning, rate limits, audit trails, and what happens when a tool returns wrong or partial data. Now a small test. Question 1. What does an MCP server mainly provide to an AI application? The answer is tools, resources, and prompts through a standard protocol. Question 2. In MCP architecture, does the host usually create one client for every server connection? Yes. Question 3. Should you give an MCP server broad access just because it is convenient? No. Start with the smallest permission that works. If you want, pause on the test screen and answer before the reveal. If those 3 answers made sense, you understand the core idea. Here is the simple mental model. An MCP server is a focused bridge between an AI application and an external system. It grew from the need to replace custom one-off integrations with a shared protocol. It exposes tools for actions, resources for context, and prompts for reusable workflows. You use it by choosing a host, configuring the server, inspecting the available capabilities, and testing safely. The benefit is connected AI that can do useful work. The responsibility is to keep access narrow, visible, and reviewable. That is the real lesson. MCP is not about giving AI unlimited power. It is about giving it the right connection with the right checks for the right job.